Alright, I'm just going to let this thing fly. I have a new theory. Well, I have a theory. And my theory is that particles spinning in a vortex away from their emission points, and I'll go through all this, are what creates the wave and the particle duality theory of photons, and they're really just a particle, but they're spinning in a vortex, a round circular spin, and that actually makes a wave. So they are a particle and a wave, actually. Now, what happens is if you took I'm talking about electrons because they're negative, they're spinning, and they're tiny, they're electrons. They're 1,800 times smaller than protons. And virtually everything is space out there. But anyway, you have to consider the source, you have to consider the spin, you have to consider the quantum state, what kind of a molecule or an atom we're dealing with, and then you can understand what's going to happen in the dual slits. Alright, so I'm saying it's a spinning vortex, and I have other videos to show this as well that are more illustrative, but let's take it this way. It's spinning out of here like this. It's coming down out of here, and there's trillions of them continuously, but they are particles, just the tip of this. This is nowhere. This is just showing you the wavelength, and that's a short wavelength. And they're virtually infinite. Now, the diameter of the spin is what dictates the quantum state of the particle. And a particle in very tight spin, the angular momentum would be enormous, because no matter where this particle is, it's doing 186,000 miles an hour. So let's take the fact that here's your proton, here's your electrons in the first shell, second, third, yada yada. Okay, that is going 186,000 miles a second. One way out here, one way out there, one way out here. They're also doing 186,000 miles a second, but they're going, 186,000 miles around because they got to go so far. They're still doing 186,000 miles an hour, but this one's going like a turbine engine, and these are going, substantially slower. So that the angular momentum of a particle, even at the weight of an electron, in this close proximity to the proton, being able to jump so many layers and drop again, it's just extremely explosive, and that's exactly what they find in hydrogen and magnesium. You can see that those are the energy levels that they absorb. Absolutely unbelievable power in hydrogen, and I have videos to show explosive sinkholes, and I'll add one to the end of this video because it's very interesting. Now, the source is emitting electrons exactly the way this will end up emitting them. So they come out of here spinning like crazy, and the bigger ones are bigger in diameter. The slower ones, not slower, they're all going the same speed, but the long frequency and the big diameter spin ones are coming down here, and then the really zoom, the spinny ones are coming down here with a lot of power. Now, there's papers that talk about shock and shock and focus shock and all this stuff, and it relates to this kind of atomic energies of hydrogen and methanes, and they understand this because of the compressed gas business. And I also see this in sinkhole collapses. They create unbelievable atomic forces, and I will show you that. Now, so when these things hit in there's bazillions, hundreds and trillions of them all the time, but they're individual particles raining down on this thing. They're electrons, negative. They spin, I believe, in the right-hand rule. So if they're going that direction, they propagate the field like this. Now that's something that is known. Now I don't know if it's a fact. Now we also know that these particles, and I'm saying they're particles because they can hit a Crookes radiometer and spin it inside of a glass dome. So I know that there's a particle coming through there, and that particle has to be wiggling its way through the glass. So they're going through there anyway. It's particles. I have no doubt. and you take the light off, it stops. There's no question. So they're particles. Now, but they're also spinning, emulating waves in a circular pattern as they cascade towards this at 186,000 miles an hour a second. Now, these are also going 186,000 miles a second. Now, think about this thing here going 186,000 miles a second, spinning at the, I mean, hey, yikes. This thing hits it, I mean, you're talking about unbelievable potentials. It's going to drop this thing out to a bazillion miles away. Now, it can't escape, or it might escape, I don't know. And that might be the shock, focus shock, I don't know. But it gets so far out there, when it drops back, the amount of energy that's released is unbelievable. And that's why these, well, this one here is not hydrogen. Hydrogen is just one of these and one of those. And then helium goes to two of these and two of those, you know, proton. Everybody knows this stuff. But when this stuff cascades into here, and it's hitting every part of every surface of the earth, and everything, when it's under the sun, when it's hitting it, it's just being flooded. I mean, like hundreds and trillions and zillions of them per square inch. It's just unbelievable. And so there's going to be a lot of stuff going on here. That's excitation. And it's going to be shooting these things off. It's just the nature of it. And you see this in this video this kid did. Is absolutely fabulous. Nice presentation. And he's got showing in the outside people looking through a box with a dual slit experiment, seeing exactly what you would expect, because you're going to have bigger and bigger and bigger and bigger ones. The white ones are going to be in the center, a little bit bigger. It's going to be, well, not white. It's going to be, you know, violet and so forth. And when you add them all together, you're going to have white. But you're going to have the really high energy ones that are really spinning, zzz, and then a little bigger, until you get down to red, and it's big, long, and the wave of it is long because it's spinning at such a long distance, and it's way out here, and it has a lot less energy, and it's not, you know, it's just a different particle, and that accounts for the quantum states. Now they're all going at 186,000 miles a second. That's all I can tell you. You're going to have extremely powerful angular momentums here. As this thing's spinning around here, you get in front of that thing, hit you, going to knock your socks off. This one over here, you might be able to catch like a baseball. I don't know. Somebody's got to look at the physics behind it and figure it out. But I'm saying that when it comes in, it literally screws itself in. And on a dual plate experiment coming through that pinhole, if it came going this direction, it would spin off to that way. If the particle was all the way around and coming back this direction, it would go off to that way. That's what accounts for these bars in the back. And the other thing is they need to use a continuous light instead of a pulsated light, red laser. That's not a good one. All right. Well, I don't think it's a good one to use because I believe it pulses, and if it pulses, you're going to get these little bumps all over the place. Where, and it might be just normal, I'm not sure, but I would use a continuous one or use the sun rays, and the sun rays produce rainbows. It's exactly what you would expect, rainbows. And on the outside edges are the red and coming into the white in the center, and they're rainbows on every one of these bumps. So, anyway, that's what you expect. That's what it shows. That's what a spinning particle vortex covers. To me, it covers all the bases. Now, I know they're going to come up with this and that, and plus it also gives you the electromagnetic wave that's going through the air as well, because they create a wave, electromagnetism, as they go through the air, negative particles. It just happens. As it goes through a wire, it does the same thing, creates a magnetic field around it. And you can take and direct these pulses of light with magnetic fields, and they did it with cathode ray tubes. So this is not something that I invented. This has been done for a zillion years. Your cathode ray tubes go back to before most of the people who are doing this stuff were even breathing oxygen. So this is not fully understood. I mean, it is fully understood. It's just that they never put it together. So that's what I got. That's what I'm saying.